All right, let's start reviewing for our virtual daily math problems that are focusing on multiplication. So all things multiplication, we are going to first start with whole numbers. So whole numbers, we are going to use our standard algorithm that we learned. So when we do our standard algorithm method, we are going to have a problem. Let's go ahead and solve this together. So get yourself a piece of paper, something to write on so we can check our answers together. So if we're doing whole numbers, let's do 427. Let's do that times 35. So I want you to go ahead and solve this whole number problem and go ahead and tell me what you get. Check your answers. How'd you do? When you multiplied everything times 5, when I say everything, I mean 427. So 427 times 5, you should have a 2,135. And then when you multiplied everything technically by a 30, but we get to just put a placeholder 0 and multiply everything by 3, did you get a 12,810? When you then add those together, your two partial products together, you get 14,945. How'd you do? Common mistakes, forgetting that placeholder 0. When you multiply, forgetting to add on what you carried. Or even an addition mistake, even though your partial products are correct. So how'd you do? Did you get it right? Let's move on to then past whole numbers and let's look at decimals. So we multiplied decimals this year, and when we multiplied decimals, it was different than adding and subtracting decimals. What was something we had to remember to do? For example, if I had 1 and 46 hundredths times 1 and 7 tenths, with adding and subtracting, we were told we need to do what? Line them up. So with multiplying, that is not the same. So if you thought, oh, I need to line them up like this, you are wrong. That's for adding and subtracting. So when we actually are multiplying decimals, we're going to ignore them completely. So I am not even going to think of this as a 1 and 46 hundredths. I'm thinking of this as a 146, and that like a 17. We'll think about those decimals when we are done multiplying. So another great chance for practicing your standard algorithm. Go ahead, solve. What do you get when you multiply 146 times 17? How'd you do? What'd you get? 2,482, I hope? Check out your partial products and see if they match up and find your error. Where is that mistake? Did you have your placeholder 0? Or hopefully you have the correct answer. But this can't be our final answer because, well, we need to consider what these digits actually their value are and when we multiply them what we would get. So I'm going to insert them back in so I can put them back in the final product. So what we can do is we estimate that this is about how much. The easiest thing to estimate are whole numbers. So this is about how many wholes. You could say 1, right? 1 and 46 hundredths? No, even if you said 2 wholes, your estimate's not going to be wrong. It's just an overestimate. So then even for 1 and 7 tenths, I would estimate this, well, it's really closer to a 2 wholes. So my estimated answer, showing my thinking here, is my answer should be about 2. Now, looking at your digits, where's the only logical spot to put this decimal based on the fact that it should be about 2? Should it be between the 8 and the 2? Should it be between the 4 and the 8? Between the 2 and the 4, or before the 2? What do you think? Yeah, the decimal should go right here because there's the only logical spot. It wouldn't make sense to have 24. It wouldn't make sense to 248. So our decimal's right where it needs to be for our final product. So now let's look at fractions. So when we have fractions and we're multiplying our fractions, it's very, again, different than adding and subtracting fractions. With adding and subtracting fractions, we get common denominators. But for multiplying, way easier. No common denominators or anything. So if we have 1 and 2/3 and we're multiplying this by 2 and 3/4, what do we need to do before we can actually even multiply it? A lot of people think that, well, just do 2 times 1 is 2 and just multiply straight across. But the fact is that there's hidden values in that one whole. There's thirds. You didn't even multiply all your thirds, and you didn't even multiply all your fourths because they're in that whole. So we need to make these mixed numbers into what? Improper fractions. So let's make these mixed numbers into improper fractions. Go ahead and show me what you would get when you change these mixed numbers into improper fractions. Solve it now and be ready to tell me your answer. Okay, what'd you get? For 1 and 2/3, you should have, because 3 times 1 is 3, and then plus 2 is 5. Should have a 5 there. And the denominator stays the same. Still multiplying. And for this one, 4 times 2 is 8. 8, 9, 10, 11. 11/4. Now we can see all the thirds. Now we can see all the fourths. And now we can multiply straight across. So when we multiply straight across, we're even multiplying the denominators. We get a 12. And then we get a 55. What's wrong with this being the final answer, though? It's a what kind of fraction? It's improper. If it's improper, we need to make it into a mixed number. Remember, as you're starting to work on expressions and you even did fractions as division, that this fraction bar also means what operation? Division. So if I take this and divide it, I can figure out what this mixed number is. Right now, go ahead and divide it and tell me what is your mixed number answer, which will be our final answer. How'd you do? So when I divided, I got 4 wholes with 7 left over. So putting that in as my final answer, I'm going to have 4, because 12 went into 55 4 times. There was 7 left over out of 12s. There's my final answer for fractions. All right, you are set in reviewing how to multiply whole numbers, decimals, and fractions. Good luck.